Hello, my name is Kevin. Today's power engineering topic is one of great concern out in the market at this current time. The use of cascading is allowed worldwide and includes South Africa. And generally, it's not the training that is offered in the real world out there does not equip your contractors and electricians for the safe use of this. It's rather a selected approach, and I would like to try and get some form of let's say understanding of the subject so that the electricians and contractors out there may approach certain companies for the information they're going to require so that they can actually deploy this type of information in the actual real world. So as we said, let's have a look at the cascading and breaker selection, and let's see if we can get some understanding of where we go with this topic. So let's have a look at the definition. So if we have a look at this definition, and under cascading, we could also term it as a series connected system, as circuit breakers generally are, but this is a series connection system where it's a systematic approach to that. So cascading is the art of putting a downstream breaker of lower capacity downstream, as we said, from an upstream breaker, which is fully rated for that. So the downstream breaker has a lower Ka than what is generally required downstream. We call this cascading, and the breaker downstream will be then underrated in terms of what you require. So if we had a main panel board rated, I don't know, it's like a 50 Ka approach, and we put that main breaker feed in there, the breakers connected below that could be substantially less, and typically they might be as low, maybe even lower sometimes, depending on the brands, maybe 35 and 25 Ka products downstream of the 50, and they are protected somehow with that. These are all short circuit level protections. This is not in the overload area. We would still have to look at discrimination being a normal overload level. Short circuit level is where we are having a look. And you basically have two fundamental areas you can look at. You can look at your main feed incomer and the section breakers going out from there. And you can have a sub dB panel where you have your sectionalizer multi-case circuit breakers and your smaller breakers going out from that panel board. Yes, and as we've said, SANS does approve it. These are the extractions from the SANS document. And if the main thing we want to point out here is obviously if you come across that label, it means it's been applied. So the main breaker upstream has to comply in accordance with the wiring codes, and it's the downstream one which will be underrated, and then fitting a suitable label, and many of the manufacturers have a label to warn you. It's got to say something as per the bottom indicated here. So if you come across this in the actual real world, it means that that system has been cascaded in terms of the performance. So when we have a look at it in the design stage, the customer may accept a cascading approach and to follow a test plan. Normally speaking, it's not a random selection of circuit breakers in the design stage. It comes from a single manufacturer, possibly, or a number of manufacturers, depending on how you want to configure your site conditions. But the consultant type arrangement will dictate, and if the customer accepts the concept, there's considerable savings In terms of the actual cost of breakers is fundamentally linked to the cost of the KA of the breaker. So breakers with higher KAs generally command higher constructional costs, and therefore they end up being more costly to the supply downstream. So, and in terms of this, high-speed breakers upstream, high-speed current limiting breakers upstream, obviously do cut short and limit the amount of short circuit forces which are applied to all the network conductor settings downstream. So basically we could say that it's a cost-based exercise, but it has to be approved by the end customer. There are quite a number of industries in our local South African environment which never allow cascading to be used. And some of them are government type agencies where they feel that initial advantage down as they go down the line is lost once they get into the maintenance thing, concepts that they don't want that to be that the guy who replaces a breaker has to just use it within the norms of the standard breaker. They don't want to fiddle around with the worry that possibly the replacement products are not used as intended and they end up with a problem on their side. So if we have a look at that, the life cycle could become a bit problematic over the years. And that's because the breakers, in this case, we will discuss how those breakers are kind of deployed, but the breakers could be stopped in manufacture. That particular model, this is a very model and brand specific approach. So if the model has been ceased in production over the years, or even the manufacturer has gone out of business, you can't really approach this at that point. You have a problem. The service personnel have to be sort of informed of these cascade requirements. So the warning label is applied, but we need to really have an understanding of what's happened in the background. And this is part of the problem. The longer this goes into the use factor time, the less that will be known. So any newcomer to the industry may not understand that the product made 20, 30 years prior and applied this way is far from the current level it's designed to do. And let's face it, there's a lack of knowledge after such a long event has actually taken place. And how on earth would you be then if you called a site to actually gather that information and to put it into layman's terms? How on earth would you get all the information required to be able to do your job that you'd like to do as a contractor? So there's a number of rules we have to take with this sort of approach. The breakers have they are published as a chart. So the breaker and the way that they have been checked and selected is up to the manufacturer. They've normally been extensively tested and approved. So whatever you see on paper has very strongly been type test proved on actual tests. Notwithstanding different models or something, the manufacturer knows what the performance is of every model that they have. And this would be a very specific in type and model that is actually quoted on the paperwork. You cannot just use any other brand and substitute. That's just not on, because it is linked to the specific manufacturer and the tests that they've done. When we have a look at this sort of approach, we could also say that you may find that your particular approach is slightly different to what's given in the paperwork of the tests. So from time to time, you may have a better idea of trying to do something and find that that option is not available in the charts. You can't just go back to the manufacturer and say, well, I'd like to do this. You need to test this, because the tests are very expensive, time consuming, and every option generally has not been tested. So the manufacturer will attempt to do high coverage of tests to support the product in being installed in Cascade format, but he will not do everything that you possibly would like to have on your selection. And so you can't go back and just ask for that. These tests are very expensive, as I said, invasive and that type of thing. So you can't just, for the sake of a single application, get a test certificate or an additional test. There's no general cost feedback to the supplier to operate on a single event. You need to also check as well that, as I said, not everybody allows cascading on there. So you need to have a look if your customer actually allows cascading on that particular plant. Don't introduce it just at will. There's obviously a buy-in from your customer. If he already has a system, you need to try and make that system survive and continually do that. The other thing is, of course, is that when you have a look at those breakers that go through these high-level short circuits, the breaker downstream, although is survived, as in it hasn't caused calamity, and the danger to the operator is controlled and contained, that breaker is not in a real good state to continue life forever thereafter. If you're talking about any breaker really at the top end of their performance, we must understand that breaker has a very limited life under that. Whereas a fuse goes bang once, a breaker may only go a handful of operations, down to this possibly 2 or 3 operations, and then a replacement is a bit of summary here. So the concept, if we have a look at the 2 breakers, this is an upstream downstream approach. There's going to be a short circuit at the bottom end there after the breakers. As we said, our upstream breaker is a high-speed current limiting type, very popular these days, and in the past had been quite expensive, but manufacturers have honed this art of getting very high KAs at a reduced cost, and the breakers are very high speed and they open relatively quickly and extremely reliable, because any delay on opening means the upstream breaker could be damaged. So the let-through current is where this whole concept is derived from. So the let-through of a high-speed breaker is very contained. So typically we talked about 50 Ka breaker upstream. And so if we had a 50 Ka downstream short circuit, this breaker would survive that type of thing. That's the incoming upstream 50 Ka job. But we must understand that the breaker is so fast and so efficient at what it does. It predicts that the short circuit is enough that it needs to be able to trip, and trip finely and fastly and in high capacity, so that the let-through energy is actually reduced. It could very well be that a 50 Ka product has somewhere between, estimation, somewhere between 15 and possibly 20 Ka let-through only. And that generally falls down to the fact that, so the breaker protects itself by being so fast and efficient, it doesn't actually see the 50 Ka. It only really sees something in the region of the 15 or 20 Ka. And that's what it's got to survive on. And because it snubs the current off so quickly and efficiently, the breaker downstream will also not see the 50 Ka short circuit. So what will happen there is, if that breaker is a 25 Ka product and it's going to only see 20 Ka, it would survive. And that's the fundamentals of this approach, is that breaker downstream is not going to be applied beyond its capacity generally to survive. And although you can do some sort of predictive type charts on this thing, most of these come from actual tests to prove that this concept works. So the manufacturer has a look, he decides, right, we could do this, we could do that. and we do that. The other thing I should have mentioned earlier was that we don't want to do a cascade on top of cascade on top of cascade, although somewhat possible. We need to keep this approach as simple as possible. So don't have extreme multi-levels that everything relies back on the 50 kA breaker backstream. And you've got cascade on cascade on cascade at every level, all the way down to a 5 kA breaker installed to feed some plant in the factory. Rather have clear-cut rules that you might have that on the incoming type levels and on the end, but it's not really a good approach to have all multiple levels, and it obviously makes it a lot more complex. Okay, so I think you guys should have a better understanding of what is required. The following is probably the key success here, is follow the cascade rules to the absolute letter. You need to get hold of your supplier, your manufacturer, supplier, and get the details that you require in terms of what is cascadable in their offering. Now that could be the CBIs, the ABBs, the Schneiders, Mitsubishi has it as well. And take that and to get a good working knowledge from that supplier exactly what is available. Any recommendations in terms of additional stuff? Now, we've talked about the combo of the circuit breakers, but they might specify that you need to have certain cable run sizes, certain cable thicknesses, certain types of connections and the like. You need to follow those recommendations if they've gone a little bit wider than just the breakers in the base format. I would also suggest as a contractor to keep the pieces of paper that you are given if you go to site and you have to go back to the manufacturer and say, look, I've got these models installed. The 5K product range has changed every, I don't know, 12, 15 years about. So it's 20 years down the line. Would your new ranges comply with that? Because now you've got a breaker upstream and one downstream, and you're not going to find that easily that when these were sold, they came out with a package deal and the products were all new and in line with what was being provided. And going down the line, your replacement product possibly will not be available from the current offering. And if you get clarity from the manufacturer, most of the manufacturers, I think, know their products pretty well. Even if they don't have curves for that, they can extrapolate because they know the particular products either perform very much the same, or that the type of grading used in the previous set of data indicates that the current range would fit the same parameters. Sometimes between models, they're just a newer update. They're not strategically that different possibly, or they may be completely different, in which case, you need to refer back to original stuff or change what's there. So, and I would say definitely obtain any clarity that you need to do on these panels. Get the service backup, get the type of backup that you do and need from your manufacturer before attempting this type of thing. Don't use a suck and see approach that could go terribly wrong in the future. All right, so I think that should cover it. Main thing, just in summary, if you are using a specific brand and you think that you will go into this cascade offering, sometimes you might be in the panel board supplier stroke manufacturing. You might be able to spec something to be made to your requirements. Go back to that manufacturer, get the details of what is in their cascade offering, and get a very good understanding of what needs to be done to ensure that that cascading happens. And there we have it. Thanks very much for our discussion.